welcome all to YouTube channel Mechanical Study, where we study different mechanical system. Today we'll continue with our thermodynamics question series, and we'll start with the question number 61. That is, thermocouples are generally used for measuring temperature. So thermocouples are basically used to measure temperature up to 1500 degrees Celsius, and it is generally used to measure temperature in the range 200 to 1500 degree Celsius. So option C will be the correct one. Which of the following is not a point function of the system? That is question number 62. So point function are those functions which can be drawn on PV and TS diagram by a point, and out of those, temperature, pressure and specific volume are the point function, but the heat is a path function. So option D will be the right one. Then the next question, that is the enthalpy of an ideal gas is a function of. So enthalpy of an ideal gas is a function of a temperature only, similar to the internal energy enthalpy is also a function of a temperature. So here enthalpy or change in enthalpy can be written as MCP dt. So here enthalpy is also a function of temperature. So option C will be the right one. The next question, that is 1 degree Celsius is equal to, for that purpose we should know the what is 0 degree Celsius. So 0 degree Celsius is nothing but equals to 273.15 Kelvin. So 1 degree Celsius will be plus 1, that means 274.15 Kelvin. So 274.15 Kelvin is in option B. So option B will be the right answer. Then question number 65, identify open system and closed system from the following. So option is blood circulation and respiration in human body, fuel system and radiators in cars. Then option C is air compressor and boiler, shell and tube heat exchanger and blower. So there are basically open system are those system where mass as well as energy crosses the boundary, and closed system are those where mass remains constant but energy crosses the boundary of a system. So I will give it up to you. So give me its answer in comment section. The next question, that is compression efficiency, is compared against ideal compression, then adiabatic compression, then isentropic compression, then isothermal compression. So basically compression efficiency is compared with the isothermal compression. The reason behind that is that the minimum amount of work will be required in a isothermal compression process. So isothermal efficiency will be the maximum efficiency for a compressor. So it is so whatever the actual efficiency that we got for the compressor, that compression efficiency is always compared with the isothermal efficiency. So option D will be the right answer. The next question, that is which thermometer is independent of the substance or material used in its construction. That is options are mercury thermometer, alcohol thermometer, ideal gas thermometer, resistance thermometer. So option C will be the right one, that is ideal gas thermometer, which is also called as a gas thermometer. So option C will be the right answer. The next question, that is the pressure of air in an automobile tire at temperature of 27 degrees Celsius is 1.75 bar. That is the gauge pressure. Due to running, the temperature of air in the tire rises to 87 degrees Celsius. What will be the gauge pressure during this running? Okay, so here initial pressure and temperature is given, similarly final pressure and temperature is given, and volume of the tire is assumed constant. That is, we have to use the equation, that is PV by T is equal to constant. So here volume is constant, so one can write that P1 by T1 is equal to P2 by T2, and here we have to find out P2. So P2 will be equals to T2 into P1 upon T1, where T2 is 87 degrees Celsius. So in Kelvin it is 360 Kelvin, and P1 is 1.75 bar, that is gauge pressure, but we have to find out absolute pressure. So add atmospheric pressure in the gauge pressure, will get the absolute pressure. It comes out to be 2.76 bar, and T1 is 27 degrees Celsius. So add 273, it comes out to be 300 Kelvin. So final answer comes out to be, that is P2 is equal to, that is P2, this will be the what absolute pressure. So it comes out to be 3.312 bar, but we have to find out the gauge pressure. So minus from that minus 1.01, that is atmospheric pressure, we will get the gauge pressure, that is P2 gauge pressure is equals to 2.302 bar. Then next question, so here option A will be the right answer. The next question, that is 69, the non-flow reversible process takes place according to volume is equal to 15 upon P meter cube, where P is in bar. What will be the work done if pressure changes from 1 bar to 10 bar, and given that is ln of 10 is equal to 2.33025. Now here relation between volume and pressure is given, and the process that is, it is a non-flow reversible process. Non-flow reversible process that means a mass will not cross the boundary of a system, and that is generally carried out in a closed system. So here we have to find out work done. So for that purpose we need to use a simple formula, that is a work will be equals to integration of P dV. So here you can apply this for equation for that is for state 1 to 2, that is at the state 1 the pressure is 1 bar and at state 2 pressure is 10 bar. So to solve this, and we can see the volume relation, that is volume and pressure relation, that is 15 upon P. Then P1 is given 1 bar, P2 is given 10 bar. Then here we can apply equation, that is P1 V1 is equal to P2 V2. From that we get the P1 by P2 is equal to V2 by V1. So as P1 by P2 is nothing but 1 by 10, so V1 by V2 will be equals to 10 by 1. So for non-flow work, that is integration of P dV. So here we can write down P is equal to 15 upon V into dV. So here comes out to be 15 is a constant term, so it can be taken out from the integral sign. So here it will be equals to 1 upon V dV. Now here pressure is changes from the 1 to 10 bar, 1 to 10. Here pressure rise takes place, that means process is compression process. As the pressure is rising, that means the process is compression process. So volume will be reduced, so reverse thing will be happen, that is initially volume will be 10 times the final volume. So initial volume will be more, final volume will be less, so we have to integrate from the 10 to 1, that is volume will get decreases as compression process carried out. So here put that in equation, so we will get the final answer, that is minus 34.538 into 10 raised to 5 Newton meter. So here again convert it into a meganewton meter, so this comes out to be 3.4538 meganewton meter. Now here negative sign indicates that the process is a compression process, means volume will reduces and pressure will increase. So here option C will be the right answer, that is 3.453 meganewton meter, and compression is carried out. The next question, that is 17th question. In a steady flow reversible adiabatic process, work done is equal to, that is the process is steady flow reversible process, adiabatic process. So adiabatic process where heat transfer is 0. So if you apply steady flow energy equation, that is H1 plus Q is equal to W plus Q2, W plus H2. Okay, suppose you have apply equation for any open system where energy and mass crosses the boundary of the system. So okay, if you apply for per unit mass basis, then we can write here as a specific enthalpy here. So here the for a reversible adiabatic process, which is also called the isentropic process, here heat transfer will be the 0. So work done will be equals to W is equal to H1 minus H2. So one can write here as the work done will be equals to change in enthalpy. So option C will be the right answer, that is for steady flow reversible adiabatic process, work done is equal to the change in enthalpy, because in reversible adiabatic process heat transfer to the surrounding is 0. So whatever the work done will be the equals to the change in enthalpy. The next question, a certain quantities cannot be located on a graph by point but are given by area under the curve corresponding to the process. Okay, so this quantities in concepts of thermodynamics are called as, so it is called as path functions. So like work and heat are path functions. So whatever the area under the curve, suppose if I take an example for a closed system executes a cycle, so in that case whatever the area under the curve will gives us a work done. If you plot it on a PV diagram, then if you plot a process on a TS diagram, then whatever the area under the curve gives us a heat transfer on TS diagram. So both are path function, that is heat as well as work are path functions. The next question, a steel tank placed in hot environment contains 5 kg of air at 4 atmosphere at 30 degrees Celsius. So initial condition is pressure 4 atmosphere, then temperature is 30 degrees Celsius, and mass is 5 kg. A portion of air is released till the pressure becomes 2 atmosphere. So for sometimes tank is open so that the pressure will get released and it becomes 2 atmosphere, means pressure will reduce Later, the temperature of air in the tank is found 150 degrees Celsius. So it is as we release the air, at the final condition, the final temperature comes out to be 150 degrees Celsius. The quantity of air allowed to escape. We have to find out the quantity of air allowed to escape. Now, initially, the inside in the tank, 5 kg of air is available at the first condition, that is for the initial condition, and after sometimes when we release the uh, air to the surrounding, its pressure becomes to atmosphere. So we will solve first this question. So initially mass is 5 kg, pressure is 4 atmosphere. So you can note it in kilopascal. So just we have to multiply with the one, that is 1 atmosphere is nothing but 1.01325 kilopascal. So just multiply, we will get the P1 value. Then T1 is 30 degrees Celsius. So in Kelvin it is 303 Kelvin. Similarly, after we release the air, then the pressure becomes 2 atmosphere and temperature becomes 150 degrees Celsius, that is 423 Kelvin. Then from using the ideal gas equation, that is PV is equal to mRT, where P is the pressure, V is the volume, mass, m is the mass, R is the characteristic gas constant, and T is the temperature. Now here we will get the volume, that is volume at the initial condition in the tank, that is mass is 5, then characteristic gas constant for air is 0.287 kilojoule per kg Kelvin. Then temperature is 303 and initial pressure is 405.3. So volumes comes out to be 1.072 meter cube. Now for the final state, when we release the gas to the surrounding, that is pressure becomes equals to 2 atmosphere. So it will be 202.65. Then volume again here 1.072. Then characteristic gas constant is 0.287 and T2 is 423. So final mass value comes out to be 1.79. Here we have to find out the amount of gas that is escaped. So at the end condition, the mass is 1.79 kg and at the initial condition mass is 5 kg. So just we have to just take a difference of m1 minus m2. This will give us the amount of air that is escaped to the surrounding. This comes out to be 3.209 kg. So the amount of air that is escaped to the surrounding will be 3.209 kg. So this will be the answer, that is option. It is given in option, that is 3.209. That means option D will be the right answer. So option D will be the right answer for given question. The next question, thermal efficiency of the hypothetical cycle shown is. So here on your screen you can see a TS diagram, and on TS diagram a cycle is drawn, that is cycle ABC. Now here you have to find out the thermal efficiency. Now for efficiency of a cycle, that is nothing but it is ratio of net work to the heat supplied. Now Q net can be calculated as Q supplied minus Q rejected. Now for the given cycle, W net can be found out, that is Q supplied minus Q rejected. Now as you all know that on a TS diagram, heat supply, that is Q supplied, can be found out as the area under the curve, and that must be equals to this much area, that is this much area will be the heat supplied, and heat rejected will be the so heat supplied will be equals to 1A B C 5. This will be the heat supplied, and heat rejected will be 1A C 5 1. So the W net will be equals to only this much, that is W net, that is Q supplied minus Q rejected. So this will be equals to ABC, area under the curve ABC. So here triangle is formed. So W net must be equals to, W net will be equals to 1/2 base triangle, that is area of triangle is nothing but 1/2 base into height. So here base is nothing but 5 minus 1, that is 4, into height is 700 minus 300, that is 400. So equation here final answer comes out to be 800 kilojoule. So here W net will be the 800 kilojoule. Then next we have to find out the heat supplied. So heat supplied formula will be the, again formula is, that is area under the curve, that is A1 A B C 5 1. So this will be the area under the curve, that is the heat supplied. So this will be equals to the sum of this area plus this area. So here We have already found this area, that is triangle area, which is nothing but 800 kilojoule. Just we have to find out the area of this much area. So that is it is a rectangle, so it should be equals to 5 minus 1, that is 4, into the height will be is this 300, so it will be equals to 800 plus 4 into 300, that is 1200. This will be equals to 2000 kilojoule. Now we have to find out here efficiency. So efficiency will be equals to nothing but W net, which is 800 kilojoule, and the heat supplied is 2000. So it comes out to be 8 by 20, that is comes out to be 0.4 or 40%. So for given cycle the efficiency will be 40%. So this will be for today's. So do like and subscribe to our channel. Thank you.